Hello everyone, my name is Rishabh Sharma and today I'm going to present our paper titled LAMNER Code Comment Generation using Character Language Model and Named Entity Recognition. Developing a software is a complex and a continuous process. It involves code interaction among different development teams. Therefore, it can be hard to understand what a particular code snippet does. It is an important software engineering practice to use code comments so that code is easily understandable to other developers. However, developers often neglect this practice and focus more on writing code. Therefore, automatic code command generation techniques can be useful in this scenario. Current works use code as input, which is then passed through the embedding layer. This embedding layer right now is randomly initialized, which makes code command generation models unaware of the difference between the tokens. Moreover, semantic and syntax knowledge of code is important in source code, which is provided with the external knowledge like abstract syntax trees in the current works. In this work, rather than using the random initialization of the embeddings, language model and NER model is used to initialize the embeddings. Moreover, this way, these embeddings can be combined with other existing works which use external knowledges like ASTs and UMLs. In this work, we present a new framework called Automatic Code Command for the automatic code command generation. The proposed framework can be divided into three parts: pre-training language model and NER model, extracting the pre-trained embeddings, employing the embeddings for code command generation. Both language model and named entity recognition model are pre-trained on a large corpus of code. Language model is trained to predict the next character, which helps the model learn the distributional prior of the source code, thus the semantic relationship of the data. NER model is trained to predict the syntactic type of code tokens, which is, in this case, whether a token is a return type, data type, or a function. Therefore, it learns the syntactic representation through token type labeling. The trained language model is then used to extract the semantic embedding. The forward and the backward pass of the language model, which uses LSTM, is concatenated and then extracted to represent the semantic representation for the source code. Similarly, the trained NER model is used to extract the syntactic embedding. Here, the code is first passed through the forward, then the backward LSTM. As CRF layer leverages the output of the forward and backward LSTM to predict the syntactic type, hence this information contains the syntactic knowledge, which is extracted at this step and later on concatenated with the semantic embedding, which has been extracted from the language model. The extracted embeddings are then finally employed into a GRU-based encoder-decoder neural machine translation model in order to generate the code comments. Now, we test our proposed work on a publicly available Java dataset and evaluate the performance on four different automatic translation metrics, which is Blue, Meteor, Cider, and Roselle. We compare our proposed work with 8 different baselines. Our results show that the proposed approach scores best among all the baselines by 1.4% to 25%. The best performing baseline was Renko's and LAMNER architecture trained with the CodeButt embeddings. Now, in order to understand what is working best in our model, we trained different models using different parts of the framework. One of the model uses a language model, another one uses the NAR model. The NAR embedding results has shown it scores better than the language model on all evaluation metrics. Finally, the combination of both language model and NER embeddings have the best score, which has been shown as LAMNER. Now, in order to analyze the adaptability of LAMNER, we combine it with other embeddings, which is embedding from CodeButt. Combining LAMNER embedding with CodeButt embedding improves its performance by 3.7 to 10%. We also employ the LAMNER embedding inside Renco's, which improves its performance as well. As shown in previous research, automatic metrics are not completely reliable as they're based on finding the overlapping tokens between ground truth and generated comments. Therefore, we conducted a human evaluation where M-Turkers were asked to rate comments on three different metrics, which is informativeness, relevance, and fluency. The results show that evaluators rated comments for LAMNers are better on all these three metrics. Finally, in conclusion, this paper presented a syntactic embedding for source code, which when employed for code comment generation, gives out better results to the baselines used in this work. Proposed embedding outperforms the baseline both on quantitative and qualitative metrics. Moreover, the proposed work can also be combined with the existing techniques. Finally, I would like to thank my co-authors, Dr. Fuxian Chen and Dr. Fatima Fard, for their contribution to this work. Thanks.